In this last video for lesson 3.2, we're actually going to prove how we know that alternate interior angles are congruent. So we're going to go ahead and do a 2-column proof. This will be really good practice to just practice using the different theorems that we have and seeing what that would look like in a proof. So we're going to go to your additional examples packet, page 1. And we're going to look at this proof here. And the picture goes with our proof here. Prove that if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. That's what we're trying to prove. We know this is true, but we're just going to show why we know this is true. They give us that line P is parallel to Q. And I can see that's my first statement, so I'm going to go ahead and say, hey, this was given to us. And we know at the end we're going to have to prove that angle 1 is congruent to angle 2. And so using our picture here, we know that angle 1 is congruent to angle 3. We got to ask ourselves why. How do we know that those two are congruent? Do they form a special angle pair that we know are congruent because those lines are parallel? And the answer is yes. Angles 1 and angle 3, they're in matching positions. They're both in this bottom left-hand corner. These guys are corresponding angles. And we know when a transversal cuts through two parallel lines, corresponding angles are congruent. So we know angle 1 is congruent to angle 3 by the corresponding angles theorem. So I went ahead and I put one arc on both of these angles to show they're congruent. We also know that angle 3 is congruent to angle 2. We have to ask ourselves, how do we know that angle 3 and angle 2 are congruent? Do they form a special angle pair? They do. They are vertical angles. Vertical angles are always congruent. So we know angle 3 is congruent to angle 2 by the vertical angles theorem. So now, finally, we can see that because angle 3 is congruent to both 1 and 2, that 1 and 2 also have to be congruent to each other. So this is that if-then statement. If angle 1 is congruent to angle 3 and angle 3 is congruent to angle 2, then angle 1 must also be congruent to angle 2. That is the transitive property we're using. You could also put substitution there. I'm going to leave it as transitive property. And so we've proven that, yes, alternate interior angles are congruent when the two lines are parallel.